సార్ నమస్కారం సార్. సార్ ಎಲ್ಲಿ ಅದು ಮನೆನಾ ಏನದು?
ಸರ್
ನಮಸ್ಕಾರ ಸರ್.
ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಸರ್.
ಗುಡ್ ಮಾರ್ನಿಂಗ್.
ಬನ್ನಿ ಕೊಡಿ ಸರ್. ನಮಸ್ಕಾರ.
ನಮಸ್ಕಾರ
ಸರ್. ನಮಸ್ಕಾರ ಸರ್. ಸುದರ್ಶನ್ ರೆಡ್ಡಿ.
ನಮಸ್ಕಾರ ಸರ್. ಥ್ಯಾಂಕ್ ಯು ನನ್ನ ತಮ್ಮ ಯೂನಿವರ್ಸಿಟಿಗೆ ಆಹ್ವಾನಿಸಿದ್ದಕ್ಕೆ ಮತ್ತೆ ಈ ಅವಕಾಶಕ್ಕಾಗಿ ನಿಜವಾಗ್ಲೂ ಐ ಆಮ್ ವೆರಿ ಗ್ರೇಟ್ಫುಲ್. ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಸರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಸೋಣ ಸರ್. ಸರ್
ನಾನು ರೆಡಿ ಇದ್ದೀನಿ ಸರ್.
ಶುರು ಮಾಡಿ.
ಓಕೆ ಮೇಡಮ್ ಪ್ಲೀಸ್.
Yes. A very warm welcome to everyone. A very warm greetings to our Hon'ble Vice Chancellor, Professor Vidyashankar. Our speaker for today, Professor Sharath Ananthamurthy, Registrar of VTU, Professor B.E. Rangaswamy, Registrar Evaluation, Dr. T.N. Srinivasan, and Finance Officer, Dr. Prashant Naik. All the college principals and our efforts that Professor Sudarshan Reddy, the Regional Director, as well as the UHV Coordinator, and all the members, students and faculty, a very warm welcome. It's our pleasure to start the present monthly lecture series, which is the 9th series, on human values and rationality in an age of science and technology. And we have an eminent speaker. May I request Professor Sudarshan Reddy to kindly welcome the gathering and have a kickstart for this entire session. So over to you, please.
Thank you, madam. Ellarigu namaskaralu. Good morning, everyone. I am Dr. Sudarshan Reddy, HR, Regional Director of VTU, Bangalore region, and also VTU UHV Coordinator. It gives me immense pleasure to welcome you all to the 9th lecture in the VTU Universal Values Cell monthly lecture series. First and foremost, I extend a warm and respectful welcome to our Hon'ble Vice Chancellor, Professor S. Vidyashankar, sir. Sir, we are deeply honored by your gracious presence today. I welcome you, sir. A heartfelt welcome to our distinguished speaker, Professor Sharath Ananthamurthy, sir, Honorable Vice Chancellor of Kuvempu University, who will be delivering a thought-provoking lecture on human values and rationality in an age of science and technology. I welcome you, sir. I also welcome Dr. B. Rangaswamy, Registrar of VTU, Dr. Srinivasan, Registrar Evaluation and Finance Officer, Dr. Prashant Naik. A sincere welcome to all our faculty members, head of institutions, and the principals of all the colleges. And last, but certainly not least, a hearty welcome to all our dear second semester students of engineering, architecture, and other courses who are joining us virtually from across the Karnataka. We hope that today's session will spark reflection, curiosity, and a deeper understanding of human values in the evolving context of science and technology. Let us look forward to a truly enriching and engaging session ahead. Thank you, one and all.
Thank you, sir. And we also welcome you for this entire event. Let me briefly introduce the guest speaker for today, Dr. Sharath Ananthamurthy, who is currently the Vice Chancellor of Kuvempu University, a distinguished physicist and an academic leader. He has over 38 years of research experience and 28 years of teaching. He holds degrees from IIT Kanpur and the University of Iowa, USA, and has held prestigious visiting positions at Imperial College London and the University of Mainz, Germany. Dr. Sharath has secured significant research funding, published in high-impact journals, and has been recognized with Commonwealth Academic Fellowship Award. He has also held various administrative roles, including Chairman of Physics at Bangalore University and a member of several committees for project evaluation, teacher recruitment, and infrastructure development. With the short note and introduction, sir, we are pleased to have you here, and it would be none other than you to have this topic on board. May I request you to carry forward your talk?
Madam, excuse me. First,
Yes.
I would like to ask our Honorable Vice Chancellor to
To
give
have-
a remarks.
Yes, sir. So can we have a keynote address of yours before we start the session?
Sir, ಎಲ್ಲರಿಗೂ ನನ್ನ ನಮಸ್ಕಾರಗಳು. It's my pleasure to warmly welcome you all to the 9th lecture in the BTU Universal Human Values Cells monthly lecture series. Today, we are truly honored to have with us the great personality, academic luminary and personality, Professor Sharath Ananthamurthy, the Honorable Vice Chancellor of Kuvempu University, who will deliver a lecture on the very relevant topic, that is human values and rationality in an age of science and technology. Universal human values such as compassion, respect, and harmony are deeply embedded in Indian culture. These values form the foundation of our society and continue to guide us in balancing our rich traditions with the demands of modern life. As we delve into today's discussion, let us reflect on how these timeless principles can be meaningfully integrated with scientific and technological progress, leading us towards a more empathetic, equitable, and rational society. Thank you for allowing me to my opening remarks, and let us look forward into an inspiring and thought-provoking session aired by the great academic luminary, Professor Sharath Ananthamurthy, who happens to be the Honorable Vice Chancellor of Kuvempu University. I welcome on behalf of myself and all my university officials, as well as the principals of all the affiliated institutions, and on behalf of the students, to this thought-provoking session, sir. Thank you.
Thank you very much. Thank you. Thank you.
Thank
Am
you so
I
much,
audible?
sir.
Yeah.
Yes, sir.
Let me first say that I'm so pleased and happy to be with all of you, although it's a virtual mode. I really had wished I was physically amidst you. Maybe that opportunity may arise too. And I'm so pleased to actually be amidst such a great Vice Chancellor who has done so well for a university which of tremendous importance, especially for us, and which attracts some of the brightest students, who graduate from their pre-university. Indeed, sir, you have an onerous task of taking this forward, and I've been also following the remarkable ways in which you have conducted examinations, produced results at jet speed time, really, and kudos to you. I personally congratulate you for this great success. I was intrigued about this topic, and especially for a technical audience, to talk about ethics, human values, and so on, I'm afraid seems a bit of a contradiction. Because we are all taught often, especially in science and technology, that a separation is a must. A separation of your the things about right and wrong, about compassion and so on, have to be put aside when you practice the art or the craft of technology. And therefore, it is indeed commendable that you have chosen that this is central today to our education, because there is a loss that we are all feeling. And I'm so happy that this topic has been given to me. And I hope to share some thought-provoking thoughts with you. And let me go to my screen. It will be a PowerPoint presentation, which will last about 45 to 50 minutes. And I hope that I will end within that. I understand that there is no discussion, although if someone really wanted to ask me something, I'd be happy to take one or two questions, but I leave that to the organizers. So I'm sharing my slides now. I want to start by saying that what you see in the backdrop there, firstly, are my slides clearly visible, sir?
Yes.
Okay, and thank you. What you see is, of course, the logo of our university, but in the backdrop, the mushroom rock that you see is not from my university where I'm currently working, but it's from the University of Hyderabad, where I used to teach till last year when I was appointed Vice Chancellor of Kuvempu. The reason I put it up is that I think it really symbolizes the precarious existence of this earth that we are all witness to today. Although the surprising thing about mushroom rock, as we call it, is that it has been balanced that way for now perhaps 1 million years. And this is really intriguing. If not 1 million, at least a few 100,000, certainly. So I want to take this as a metaphor for what I'm going to say today, also with a caution that the mushroom rock is facing a destruction because of the recent incidents at the University of Hyderabad. But that's another story. So let me go to the next slide. Yeah. So I will start by raising two provocative questions. Now, our Honorable Vice Chancellor, sir, talked about compassion and so on with reference to human values. I would add to that a central human value. It is almost being escalated to a value, and this is the value of curiosity. That curiosity is what drives modern science and technology. Indeed, this is something of paramount importance to us, because this is what we nurture in all our universities. And going by the famous Vannevar Bush, who talked about the endless frontier in research, it also therefore entails a kind of an unbridled curiosity, something that has no bounds, that you want to try out just because it's out there to try out. I want to ask whether such an unbridled curiosity is a value in today's world. And indeed, if it is, should it be nurtured? And if it is not, what options do we have? But I'll give you a caution. I'm not going to answer this question, but I'm going to leave it to my very smart audience out there to figure out their own answers, because there really isn't an answer. So I want to leave this as an open question. Next.
Sir, make
Yes.
it full screen, sir. Sir, that your PPT, make it full screen, sir.
All right. I think this is full screen, right? Okay. Please give me a second.
Yeah, sir. Make now it is full screen. Sir.
Is that okay, sir?
No, sir. Once again, it has come back.
Oh. Okay.
Now it is okay, sir.
Is that okay? Yeah.
Yes.
All right. All right. So it's not in the PowerPoint mode, but that's all right. Yeah. Next slide. Yeah. So what is it about science and technology? Today I just want to give two examples here that to really underscore the fact that science has not only seriously intervened in our lives, but it's also going to shape the way we think, shape the way we interact, shape the way we transact in the world. And, I'm really excited about two areas really that I think hold great promise. One is optogenetics, where you can use proteins that are sensitive to light to really map out the ways in which the brain works and what neurons are stimulated by what thought processes and so on is becoming actually tangible to us. And let me just do this. Yeah. The other thing is in quantum information and quantum technologies, where we are now witnessing an amazing revolution. And the guy you see down there is Vijay, who is a very promising physicist at the Tata Institute of Fundamental Research. I think it's Vijay Raghavan who's really built India's first 8-qubit quantum computer. What you see up there is a slide from a colleague's lab of, I think that's about 9 calcium atoms, ions actually, which are single ions, which are arranged in a row. So these are promising hardware for qubit manipulation. Now, while this is also true, the following is also true. Death and destruction. We also see that precision airstrikes are possible with today's technology. And almost there is no place in the world which is out of our reach. No corner really which is out of our reach, from prying satellites and from very, very accurate missiles. So that is there. War-induced destruction and famine is also something that we are increasingly seeing all over the world. We are almost on the brink of extinction. A small trigger on the nuclear front can cause havoc. And worse, there is a warfare of every day, and this is the climate crisis, which is affecting us in small ways and in very big ways. And what you see there are just representations, wildfires, the pollution due to leakages, and landscapes laid waste, marine life seeing destruction, and so on and so forth. So what does this all mean? Often science and technology are regarded as a knife which can either work to help us or work to destroy us. Now, I want to examine this metaphor in the context of what I want to say. Let's start really by talking about animism. Right. Now, again, your slides will be a little smaller, but I hope you can bear with this, because this seems like sir, is this all right? Can you bear with this slide?
Sir,
Yes,
sir,
sir.
it's all right.
Yes, sir.
It's all right.
Is that okay?
Yes.
Okay, fine. So let's start with early notions. So animism is a place where you can actually see some form of integration, wherein all sentient creatures and everything in the physical world seem to have a spiritual essence. And this is the way in which our ancients used to conceive of the world, that there was some kind of a life force in the whole universe. Now, whether this is true or not, what it did promote is the essential need for harmony in nature. Now, and let's start with animism, but that's not the only thing. If you look at the early philosophers, the Greeks and Aristotle especially, there was, although there was a recognition that everything has some kind of integration, there was a clear idea of situating things of the mind, but the mind itself is being situated in matter, and the contemplation as to the eternal forms and so on. So where does this schism or this bifurcation start to happen? And to answer this, I would like to take examples from Western developments, primarily because notwithstanding that India and other civilizations too have had remarkable contributions made, the path taken today clearly is Western science and technology. And therefore, we have to pay attention to what has been happening there. So I really think the separation of knowledge from the knower maybe starts from the Renaissance. So just a brief idea of European Renaissance. That was the first step where, in a beautiful convergence of art and science, many things about science started to be unraveled. And I would say that if you look in European history, really curiosity and study of nature and the physical world saw its first outlet really in the Renaissance. Although the Renaissance thinkers were steeply immersed in the divine, in the contemplation of the divine, there was certainly a curiosity, increasing curiosity of the physical world out there. And what I'm showing you there is, of course, no prizes for guessing. It's the famous Vitruvian Man, a sketch by Da Vinci, and that with extensive notes. So what this underscores is how Da Vinci and others were curious and practiced exact forms and proportions. You know, the idea of proportion and ratios and so on became central to the act of knowing and knowledge, and also perspective. The idea of perspective in paintings came about. But this was not without the Renaissance itself borrowing from Indian and Middle Eastern, Arab especially, scholars and philosophers. So there was a beautiful confluence of these different cultures that came in expression in the Renaissance. Another famous Renaissance painting, of course, is the Academy, which is, this is again something that you all perhaps seen. This is Raphael in the 17th century, if I'm not mistaken. And what you see there is a great, they're lying all over the place. These are all the Greek philosophers. You can see Socrates, you can see Aristotle, you can see Plato. They were not all contemporaneous, but this imagines a place where everyone in the university. So this is the early form of a university in the West. Of course, we had Nalanda and so on, but they came much later. So the academy is a place where ideas are exchanged. And I'm saying this for a purpose because I'm going to revisit the modern academy, right? And of course, what you see is a teaser below, because I also want to talk about these two approaches in knowledge construction. So that's the Renaissance. But the 17th century, the 16th, late 16th and 17th century started to see what we call the scientific revolution. And this is the first clear step where what was known as the practice of natural philosophy became science. And this was because of early Copernicus. And incidentally, Copernicus, we now think, may have been influenced by the writings of Nilakanta Somayaji from our own Kerala. And but this is arguable, and but there is some kind of evidence to that. So it also underscores that there were connections in that. Then, of course, Galileo and Kepler, who really codified, in a way, planetary motion and led to the first steps of what we can call a modern science. Okay, so the birth of astronomy is really important in this. Of course, one has to mention the outstanding work of Galileo. And Galileo is really called the father of modern science because it was he who underscored the importance of empiricism, of learning through experiment. And what I've shown again are through Renaissance depictions of Galileo. Galileo is there showing the Earl of Venice to peer through his telescope. And the story goes that actually when Galileo pointed his telescope to the moons of Jupiter, the Earl of Venice first refused to look into it. Why? Because you should not stare at the heavens, which is a creation of God. This was the Christian theological dogma at the time, and therefore he was very hesitant to doing this. So an act of encouraging to look at the world, to make observations, really comes from Galileo. But this is also leading us slowly to a certain attitude about science. And of course, I'm a physicist, so I can't but mention the great Newton. To me, he's the greatest scientist of all times, perhaps competes with Einstein. But nonetheless, you know, the first framing of the laws through his work of Principia, now that's really outstanding. But there were things that troubled Newton too. He couldn't figure out why his laws seemed to imply action at a distance. And that had to wait till Maxwell and the concept of a field to really address that. But I'm not going to talk about those. So here you see the coming into age of modern science. But what this led to is something that I'm next going to address. And I want to talk here about the idea of dualism and relate it to how today we conceive of the world and why a human value should restore non-dualism. So now we come to Descartes. I'm sure you all know or have experienced Descartes through early high school geometry when you do Cartesian geometry. But René Descartes was a philosopher, and he did many things, but he's best known for the explicit discourse on the dualism of mind and body. Now, this means that Descartes clearly said that the physical world out there has nothing to do with the processes of the mind. There is the world to be known out there, and then there is the knower sitting here, and then often they are separate. Always they are separate is what Descartes believed in. And further, he was responsible for perfecting deductive reasoning. The syllogisms that we are familiar with come from Descartes' idea of deducing things. But this actually helped the growth of science at the time, because there was the sticky thumb of divinity coming into everything. For example, I already referred to Galileo's disciples' reluctance to stare into the telescope. Because ದೈವ ಇಚ್ಛೆ ಅದು ದೈವ ಕ್ರಿಯೆಗಳನ್ನ ನಾವು ನೋಡಬಾರ್ದು. We can't stare into things that are God's creation. Now, by doing this, by saying, look, that is a matter of the mind, but the mind can study the things out there, okay? By saying that, he has actually enabled investigations in science to move at an unfettered pace. Okay, that was really what he did. But there was something else that is also owed to Descartes and later to other thinkers, and this is the concept of reductionism. Reductionism is a very powerful tool in science and in technology. For example, those of you who do finite element analysis in engineering would know that the power of reductionism. And reductionism comes in different forms. It comes in the form of methodological reductionism. It comes in the form of ontological reductionism. And reductionism is basically the idea that you can either understand a complex thing in terms of the simple parts that make up the complex whole, or also that if there's a very intricate thing where there are many involved parts, you start by understanding their simplest elements and then put everything together. Now, today we know that reductionism doesn't always work. There is the ideas of emergence and complexity, where the whole is simply more than the sum of its parts. But nonetheless, reductionism, I think in 99% of the cases, has been an extremely powerful tool. Okay. And what you see out there is basically a reductionist model of the digestive system, which is to conceive of the whole digestive system as a machine. As a machine where if you understand how the gears and how the pulleys and so on move, you can use this as a model to understand digestion. At least this is what Descartes and others were doing, till someone had the brilliant idea of cutting open these things and then actually understanding physiology and so on. But nonetheless, this is still a useful model to work in reductionism. Something else that is amply reductionist, again, as a physicist, I would want to share this, is the guy out there. I'm sure some of you engineering students who are very interested in physics would know this very colorful character called Richard Feynman. And Feynman was one of the most brilliant physicists of the 20th century, also really playful. He played a lot of mischief in the Manhattan Project, but he was a genius. And when Feynman was asked to convey a bit of knowledge for the next generation, suppose, say, we all get destroyed in a nuclear event, but we have to leave a bit of knowledge for an intelligent generation. Now, intelligent generation itself is a kind of oxymoron in the current situation, but nonetheless, I won't provoke you further. But so he said that the only worthwhile thing that we can say is that everything is made of atoms. Now, that is the ultimate reductionist principle, that you can actually, if you have a knowledge that everything is atomic in nature, you can construct all knowledge from there. Now, that is something really provoking. But we are still hanging dangling the carrot of where this leads us to. So we have dualism, we have reductionism. Let's keep both of them in the back of my mind and proceed to a very famous philosopher of science, Francis Bacon. Now, here is where we start seeing the scientific method explicated, but also the idea that this method is good because it can be used to control and manipulate nature. Okay? And explicitly, Francis Bacon comes up with the idea that nature is a handmaiden of science. Andre, nature irode namma balkegoskara. Hage, it is an engine of discovery. The scientific method is like an engine of discovery. You apply the method, you get the results. And I will not lecture you on what the scientific method is, but I want to underscore here that look at this thinking. In this thinking is the idea that nature can be manipulated and controlled in any manner that we choose to. And one does not have to be cognizant of what exactly you're doing to nature and the consequences, the long-term consequences of this. Plunder, exploit, control. These are the kind of metaphors that one comes away with. And so there you're already seeing a separation of the ethical from the scientific. And so Francis Bacon was great. He really defined very clearly. He was a very logical thinker, but he was immoral in some ways because he never thought about what this kind of plundering approach is going to do to everything. Finally, in this, what emerges is the 19th century view that which was prevalent, that the whole universe is like a giant clockwork. Look at this. This is such a mechanistic model. It's conceiving of everything as a mechanism. You can study the mechanisms. What you see there is a beautiful picture. If some of you will travel to Prague in the Czech Republic, you will see that there is this clock. I think it was built around the 17th, 18th century. So it does show the planetary movements. By the way, Kepler was there in Prague. So this clock is really worth visiting. And but the whole conception as the giant clockwork mechanism is what I want to highlight here. To look at the universe as if it's all parts and nuts and bolts that are working in conjunction with each other. So this is quite a move away from animism, isn't it? And so that's about the scientific revolution. But added to this was really the Enlightenment, the kind of the culmination of all this in the late 17th century up to the 19th century, with the important points that humans shape their destiny. So finally, we have come one full circle around to say that it's no longer, well, divinity is there, but it's out there as a separate thing. And really, man is the controller of what is called reason and things of reasonableness. And of course, alongside with it came the idea of the universal rights of humans, human rights, the notions of egalitarianism through Rousseau's work called Social Contract, and so on and so forth. So this was really what, and of course the French Revolution too, which all culminated in ideas about human rights and things like that. So to summarize the Enlightenment, once again, is the notion that man shapes his own destiny, the age of reason. So reason and rationality start to dominate, okay? And the separation of divinity and matters of the world. So this is really where we are at for the moment. But all this now has led to some words of caution. When this was happening in the early 20th century, actually around the time of the Nazi period, there was an interesting philosopher. Although many of in Europe later dismissed him as having cooperated with the Nazis and so on, I'm not so sure whether that is entirely true. He's a great philosopher. His name is Martin Heidegger. And Martin Heidegger gave a lecture called On the Question Concerning Technology. And this is one of the most important things in I want to say what Heidegger said. Heidegger said that it's not only that we simply make some discoveries and then let it to humans to decide whether it can be used for the good or bad. He said within the whole process of making that discovery, you have already embodied the transformation from it being just a curiosity-driven thing to something that you will be technologically exploited. Andre, ನಮ್ಮ ಪ್ರಕ್ರಿಯೆ ಎಲ್ಲೇ ಅದು ಅಡಗಿದೆ ಅಂತ. ಪ್ರಕ್ರಿಯೆ ಇದಕ್ಕೆ ಭಿನ್ನವಾದಲ್ಲ. ಅಂದ್ರೆ the way in which you even think of, for example, reductionist idea throws away the notion that everything has a divinity. Okay? So when you do that, it is possible, therefore, to become very clinical about what you study. And in fact, Heidegger said that with the advent of modern science and technology, we started to even view nature as a potential source for exploitation. So today we can't see a beautiful green hill without saying, oh, it must be rich in iron ore content. Or we can't see the beautiful Joke Falls without saying, hey, let me put an electrical generator down there. Now don't mistake me, I'm not being pejorative about this. But I'm saying that this has changed when we view nature, the way in which nature was viewed by our ancients, and which is viewed by us through the lens of modern science and technology is quite different. And Heidegger called this as enframing. Enframing is a human drive for a precise, controllable knowledge of the natural world. Enframing compels us to view nature as a standing reserve. Okay? And so I think Heidegger is very important for us to start thinking about how we think about nature. Of course, this was not just a thought. The most important thing, if you ask me, for a big paradigm shift in the way in which science and technology was viewed was the coming together of science and politics. And what you see there is something that Oppenheimer was made to invoke the Bhagavad Gita when he saw that it's the atomic explosion. But this was really driven by United States military interests, and there was a strange coming together of science and politics at that juncture. Now, we can all debate whether this was useful, whether this was really necessary or not, but nonetheless, what this did was it empowered scientists tremendously. They came into the center of all politics. And this is more or less what has driven developed countries today. So I'm almost actually coming to the end of my talk, and I didn't want to make this but we will now shift to the scenario that we have now, and what is the road ahead? What is the road ahead? And I'll just state what I feel we must be focusing on. And I will also talk about the kind of university knowledge that we would need to promote if we want to keep sustainability as the prime focus. That if we can't afford to say We can have unbridled curiosity about things and we can do anything. But then we have to ask the next question. So how do we curtail our curiosity, or what is the yardstick by which we can say, I will do this, I will not do this? So that is the next question I will do. So the road ahead. Let us start by saying, I think we have come to a juncture today where we will need to censure knowledge systems, because we can see in front of us the dangers of all kinds of knowledge systems. AI, for example. That's another story that we will need to save for another day. But let's start by saying, can we keep only those that we are sure will promote sustainability and protection of the environment? And further, this needs to actually go back to a holistic perspective. And I didn't want to use holistic so far because that's become a kind of a cliche. We use it in all kinds of things and it's lost its sheen. But nonetheless, I'm forced to use it here. So what is this holism? So let's look at it in the context of our own universities. And we talk endlessly about this, but I'm afraid to say, and I'm also the Vice Chancellor of a traditional public university here, we have sort of forgotten the central role of research today, which is really to situate it in interdisciplinary activity. We have come, it's clear today that problems don't ask us for subject disciplines. They ask us for solutions. And to find a solution, you can't today find any solution unless the expertise of a large number of diverse people is brought together. And this includes often the coming together of art and science. Again, like the Renaissance, we need a modern Renaissance. And this is necessary for all activities, knowledge acquisition, creation, and more, again, another cliche, innovation, to forge new ideas, new knowledge, new products. In this context, I would be failing in my part to also, there is so much talk now about IKS and Indian knowledge systems. I think this is central and important. It's also a recognition that, other cultures were also, and other civilizations were also active, but we can't simply pay lip homage to this, because let's not kid ourselves. What we are following is the Western model, the Western science and technology. So I think in that context, it's very important to ask, whether we are looking at things simply as historical, or is there some current relevance to that? And there are both views in this. We should put both views together to examine this. We can't talk about things with any agenda here. So there has to be openness. Just as our ancients in India were so open-minded, we have to follow their same open-mindedness and ask the questions, where does this align with modern science and technology? Are the knowledge systems commensurable with modern systems of knowledge, or are there some incompatibles? Especially in the concept of Ayurveda, this becomes very important. And here I am reminded of Professor Rodam Narasimha, who was one of our greatest aviation engineers and really a polymath and a great scientist, who put this idea that, the way in which Greek science and Indian science progressed, or our mathematical traditions have progressed, are different. That whereas they followed largely an axiomatic approach, proofs, theorems, and so on, for us it was Drugganita. Things that are algorithmic, that you follow certain methods to calculate something. And whether the existence of a number or a concept was of secondary importance. So it was a more practical approach. So there are all these approaches, but it's nonetheless worth examining them very seriously today. Very seriously to also give us confidence that not everything happened only in one corner of the world. And secondly, to see that humans all across civilizations and in different times have had convergences, have had divergences. And this is what knowledge is all about. So underscoring once again that we need today interdisciplinarity in our universities very seriously. And the interdisciplinarity exercises will lead us to new values, certainly, because if we bring in ecology into our, we can't do ecology today without being ethical about the practice. So I think changing our education and transforming it is not only useful to bring in innovation, but is also useful to promote sustainability. And so I will largely end with this. This is the sutra. We have to have a balance between environment, equity, and economy. And any human values that are going to promote this are the values that we have to keep. If it means an integrated view of things, then so be it. If it means giving up some of the things in the interest of